at most. The only thing that we have went outside as humans is our solar system. So we don't know what our galaxy is, but then we have enough understanding of physics and enough faith in science that we can say that our own home is just like this. So let's zoom in one of the small parts of our neighboring galaxy. And you see this, there is this odd image. These are actually two dead stars. And I'm going to call them dead stars. I'm not going to call them black holes. Because until few months ago, we didn't know black holes exist or not. What we did know is that stars die. Apado taro atyana, apado sun is a Javani mache, right? It's a half age group mache. Eventually it's gonna die, but it's not gonna become a black hole. Only few stars which are very big, very heavier than sun actually becomes a black hole. And the another curious thing is stars always are born in twins. They are always in judka ho and irte tha. And our sun is a very rare that does not happen that way. So you see two stars, and then when you have two stars which are orbiting around each other, and if there is no force other than gravity, but obviously they are going to be attracted to each other. And what happens when two stars attract to each other? Well, they just merge and become a bigger star. Right? This is a simulated image from one of our supercomputer simulations. This is not a real image. But one of the things I want you to focus is this twisting of light in the background. So this is not the gas around the stars. This is the starlight, જે આપણે last photograph જોયો, right? The couple of galaxies and all. એની પાછળથી જે light આવે છે, જે આપણા અર્થ પર અત્યારના આપણી આંખોમાં પહોંચી જોઈએ, that actually gets twisted here. And that gets twisted around a black hole. And this is why you see the sort of a distortion કે જ્યારે આપણે લેન્સમાં પેલું twisted curvature વાળું lens હોય, the kind of distortion that you see of your image is the same sort of a distortion we see from the background light. Right? Okay. Okay. All right. So what happened 100 years ago? Well, 100 years ago, one smart gentleman who was already quite famous for his age and for the time wrote the most remarkable scientific paper in human race and definitely in his career, if not the human race. And that paper was called the General Theory of Relativity. Now, why the word general? You know, because 10 years pehla he wrote a paper called Special Theory of Relativity. And the reason that one was special and this one is general was for the very simple reason, in 1905 he didn't understand gravity. He knew there is Newton's gravity. And Newton's gravity has been there for last, 300 years before Einstein came. So he was targeting something else. He was interested in how light works, how the speed of light is constant, those kind of ideas. And after he got famous in 1905, was nominated for Nobel Prize, he started working on gravity, and his mentor, Max Planck, I don't know how many of you heard of Max Planck, but Max Planck told him, don't be stupid. There is nothing wrong with gravity. Why? Why there is nothing wrong with gravity? Well, sun goes around, Earth goes around the sun, moon goes around the Earth, and everything looks perfect as how Isaac Newton had described 300 years ago. But there was something very fundamentally wrong about Newton's perception. And why? Is because આપણે એવું કહીએ કે okay, why is Earth going around sun? Well, the sun is having the gravitational pull. Okay, fine. કાલ ઉઠીને આપણો sun black hole થઈ જાય. Then what happens? Well, light આવવાની બંધ થઈ જશે. Light આવવાની તરત બંધ થઈ જશે? ના. It takes 8 minutes. Why it takes 8 minutes? Because the distance સૂર્યથી આપણા પૃથ્વી સુધીનું જેટલું ટાઈમ લાગે લાઇટને ટ્રાવેલ કરતા takes 8 minutes. And nothing travels in the universe faster than speed of light. So that's why it's going to take 8 minutes. And the same holds for even gravity. You know, why would gravity be any different? So he had this whole notion, and he said, you know, there is nothing called gravity. Gravity is actually an illusion. And that's silly. આપણે ધરતી પર અત્યારના ચોંટીને ઊભા છે. You know, we are attracted. If I drop this, it's going to go down. That means the earth is pulling something down. That is how there is a force which is something pulling down. Well, that's not really true. If you think The same system, let's say આપણું sun and earth. Think of having ઘરમાં એક મોટી ચાદર, right? અને ચાદર પર તમે એક બહુ જ ભારી વસ્તુ મૂકી દો. So what happens is there is a pull, right? There is a full pull down થાય. And once you have that pull down, let's say you take a small marble and you throw the marble with some speed such that કે marble પેલી ચાદર જે બેન્ડ થઈ ને એના કારણે એની આજુબાજુ just ફર્યા કરે. Right? Now, was there gravity in the whole process? No. But that is exactly what happens in our sun and earth system. You have sun, which is a heavy object. ये आखा universe ની એક પ્રકારની ચાદર છે, which Einstein called the space-time fabric of the universe. That whole thing is pulled down, and then you have earth, which then goes around because it started with some speed, the speed which even the marble has. And this is what he said 100 years ago. It never got proved, and of course this didn't get proved for time that Einstein was alive, and he didn't win a Nobel Prize for this. In fact, most of the people of this era thought this is one of the most craziest theories that mankind or any scientist, at least respected scientist, has came up with. Just to give you perspective, what was also 100 years ago, I'm talking about 100 years means before any of the big wars, like World War II or World War I, had actually taken place, the kind of inventions that we have around. This is Baroda 100 years ago. And in Baroda, you can see that ત્યારે આપણે બે હાથી વચ્ચેની fight જોતા હતા. And this picture is a little, gives an existential thought. કે આ ક્રાઉડમાં જે બેઠું હશે એના ભાઈનું દોસ્તારનો છોકરાનો છોકરો ક્યારે ને ક્યારે he would work on Einstein's theory and come and speak to Barodians about this, right? But this is not the craziest thing in Einstein's theory. The problem was Einstein's theory, no matter how crazy it was, gave products to two more crazy things. One of them is black holes. So what is black hole? Ekdam simple example. You take a ball, tennis ball, and you throw up. It comes down, right? Now if you want to throw a tennis ball up so that it never comes back, then you have to throw at a speed which is called the escape velocity, which is 22 kilometers per second. That is the speed at which like ISRO launches a rocket, and that's why rocket doesn't come down, right? So that is the escape velocity. Now if you had more mass or more dense object, the escape velocity increases. એટલે તમે અગર કાલે Jupiter પર જાઓ, then you need much more energy to throw a rocket outside Jupiter than you need on the Earth. So now, what if the object is so dense that even light cannot escape from it? So what happens? If light cannot even escape from it, that means nothing in the universe can escape from it. Once you are in a black hole, you are stuck forever. There is no known law of science or physics that tells us how to escape from a black hole. And this was known within few months after Einstein published his paper in 1915. In 1916, this was done by Carl Schwarzschild. And that's why, in popular culture, it is called the creepiest object in the universe. Now, typically, there is a misconception કે black holes તો છે જ ને બ્રહ્માંડમાં. તમે કેટલા બધા photographs જોયા છે, નાસાના તમે images જોઈ છે. Well, that's not really true. Until 2015, we never knew a black hole existed. What you saw was a heuristic argument. કે let's say if something આપણા સૂર્ય કરતાં 100 ગણું મોટું હોય, તો 100 ગણું મોટું એને રાખવા માટે એ કેવી રીતે stable રહે, right? So we just didn't know of any known physics. We keep calling it atlu motu hoy to black hole ho jaste. But that was not the black hole as predicted by Einstein's theory of relativity. Right? So that was one crazy object. And the other thing was very less understood was how do they even form in the universe? Right? How does a star, apna sun jo star, collapse and one day become a black hole? And so after Einstein wrote this paper and we knew about black holes that can exist in his theory, until 1956, one of our very renowned fellow Gujarati, Prahlad Chunilal Vaidya, જે ગુજરાત યુનિવર્સિટીના વાઇસ ચાન્સેલર હતા and one of the most legendary mathematicians of all time, wrote a seminal paper which proved how you can collapse a star that eventually becomes a black hole. And I'm talking about 1956. He was a Gandhian, quit India movement ma involved hata, still got his PhD and wrote this paper. And he did also a lot of other work. He was the first કે ગુજરાતી સાહિત્યમાં પોપ્યુલર સાયન્સની ચોપડી લખનાર વ્યક્તિ પહેલી વાર કોઈ હતું તે પ્રહલાદ ચુનીલાલ વૈદ્ય હતા. And it's a little sad કે I mean he was alive until 2010, and even I, being from Gujarat, was not really aware of the giant that he was in the field of physics and mathematics. The another crazy thing was gravitational waves. Now this is a little difficult to grasp what we mean by gravitational waves. So I told you, right, that let's say તમારી પાસે એક sun હોય અને તમારી પાસે એક earth હોય અને the sun and earth are going in like circles, right? And what happens, because they are going in circles, they create some sort of આપણે ચાદરમાં ધક્કો મારે તો કેવી આમ પેટર્ન નીકળ્યા કરે. Or the other way of thinking, let's say you have water and you throw a stone, and what happens once you throw a stone, there is a ripple that causes across it. And so because of that ripple, there is this kind of disturbance જે આખા બ્રહ્માંડની ચાદરને ખેંચીને ખેંચ બંધ કર્યા કરે. That is called gravitational waves. So think કે તમારી પાસે એક પીવીસીની પાઇપ છે, રાઈટ, સીધી એક જ રેડિયસની પીવીસીની પાઇપ છે and a gravitational wave comes. And what happens is કે આખી પીવીસીની પાઇપ ઉપરથી નીચે સ્ટ્રેચ થઈ જાય અને ડિસ્ટોર્ટ થઈ જાય. Now gravitational waves are around us all the time. હું જ્યારે મારો હાથ મૂવ કરું ત્યારે પણ હું gravitational waves ક્રિએટ કરું છું. But the question is, what kind of gravitational waves can we see, right? What kind of the ones we can detect with the current understanding of technology that we have? And that is when in 1970, a group of few crazy physicists came up with an idea. Okay, gravitational waves, let's say they exist in the universe, they come from a system like the sun એકબીજાની આજુબાજુ ફરી રહ્યા છે, કે બે બ્લેક હોલ એકબીજાની આજુબાજુ ફરી રહ્યા છે. અને in 1970 they made a concept design કે આપણે 4x4 કિલોમીટરનું એક વેક્યુમ ચેમ્બર બનાવીએ. And in that vacuum chamber we are going to find, and because the gravitational wave would come, આખું vacuum chamber ની size, it would shrink and stretch, and your whole experiment would change, and then you will be able to see this effect. Okay, what was the funding? $500 million. Wow, fine. So you want to build something which Einstein proposed a good 50 years ago, which no experiment has seen so far. We really don't even know if gravitational waves or black holes exist. And you want to build a 16 square kilometer instrument to find it. And you need half of the more budget than any science project out there in the world that time. Clearly, this was very crazy. And nobody funded it. So in 1970, we had the design, and to convince the government agencies that this is still a feasible project, it took us 20 years. 20 years just to convince to be funded. And after that, the construction time took 10 years to build this one of the most expensive and ambitious instrument ever built by mankind actually. It finished construction in 1999. It started collecting data. 2010 સુધી it kept running, saw nothing. So they went again to the government, we need more funding. And this was like the ultimate push. This was like, if you don't find gravitational waves, then that is it. This field is over. There is no need to pour more resources because there is more important science we do. You can't detect black holes, and you are saying that you are going to take funding from what is used for cancer, what is used for diabetes, what is used for much more important things to mankind. This was actually the time Jara detected Bantho that I was applying for PhD program. And just like Navrachna in my university, they also invited a lecturer, and he had won the Nobel Prize in physics that year. So I asked him, I want to do gravitational waves, which I was doing since my bachelor's for last 4 years, and I want to continue do my PhD in this. I said, this is crazy. you can detect